Okay, I'm going to assume that you went out and bought yourself a protractor or stole one from one of your kids. Before we start jumping in and using the protractor, I wanted to point out a couple things. One is if your protractor has a set of crosshairs as your 0 point, that's a good thing. That'll help you out a little bit. So you want to find that 0 point. That 0 point, the crosshairs here, you're going to put on each successive joint starting with your elbow joint. Okay, so crosshairs at a joint. Also want to note your scale. In my case, my protractor has two scales. One starts with 0 on the right hand side, so it goes 0 degrees, 10 degrees, all the way over to 180 degrees. It also has, and yours may or may not have, but mine also has a second scale that starts with a 0 on the left hand side and it runs through 180 on the right hand side. Okay, so if yours has two, that's very helpful, but you always want to check, are you running the right direction? Okay, so what we're looking at is finding the angle of each body segment from the successive joint starting at the elbow. We need to use the same coordinate system that ErgoWeb uses, and the coordinate system here I have at the top of the screen. The coordinate system starts with 0 as the x, the positive x-axis, what we're usually thinking is positive x, or the horizontal axis. This is 0 degrees. Somewhere between 0 to straight up 90, somewhere would be, possibly 45 degrees. Once you pass 90, you head over to, for example, 100 degrees, 120 degrees, over the direction opposite of 0 is 180 degrees. Once you pass 180, you might have 190, 200, 210, 215 degrees, and so on. Directly downward is 270. Once you pass 270, you have 300, so on, until you get back to the 0. Back to 0 is equivalent to 360 degrees. And so we're going to try to find each body segment angle based on this coordinate system. Starting out with your lower arm, we're going to put our protractor, we're going to line up our protractor at the elbow. And so if I have my photograph or my image such as on this screen, I start by putting a set of crosshairs onto the elbow. And so I've just drawn this horizontal crosshair. Next I'm going to add a vertical crosshair. Once I get those two, then I'm going to line up my crosshair and my protractor directly on that. I'm also going to draw because my protractor is bigger than this image is, I'm going to draw a line extending the lower arm out so that my protractor will actually cross that lower arm. Okay, so as you can see, I did this on pen, pencil, and paper and just took a picture. I've extended my lower arm out so it does cross my protractor. Since the lower arm is pointing downwards, it's below the horizontal, I have to flip my protractor down in order to get an angle so that it does cross the protractor. Okay, so whenever I first showed you the protractor, it was upright. In order to get angles lower on the body below the horizontal axis, I have to flip my protractor. Flipping my protractor means that I've gone from 0 to 180. And so anything beyond that I'm adding to the 180. So I've gone 0 to 180 here, so it's going to be 180 degrees plus something. The plus is starting from 0, 20, 30, 40, 90, 100, 110, 140, 140, 148 or so is where the lower arm projection crosses the scale on the protractor. So I'm going to add 180 to that, or sorry, 148 to the 180, and I'll come up with a total angle of 328 degrees. Okay, so my lower arm is pointing at an angle of 328 degrees from the horizontal. Okay, notice it stops at 328 versus my scale would go all the way up to 360. Okay, so this is 328 degrees. That's my lower arm. For the upper arm, I want to do the same sort of thing. I want to put my crosshairs now instead of doing the elbow to find a lower arm. I'm going to put my crosshairs at the shoulder. So I've drawn my first crosshair, draw my second. I'm going to go ahead and extend the horizontal axis. I didn't mention that the last time, but extend the horizontal axis so I can put my protractor on it. I'm also going to extend the upper arm. Just extend it so that it'll cross my protractor. I'm going to put my protractor on. This is all below the horizontal, so I'm going to put my protractor on this side again, so an upside down protractor. I'm going to add the 180 on top, and then find this length here to add to 180. I'm sorry, not length, this angle right here to add to 180. Okay, so the angle of the upper arm. Doing that, again, I took a photograph, so I add my 180 plus this angle here. I see that my upper arm crosses the protractor, and again, using the right scale from 0, using the red scale, 0 to about 118 or so. Okay, so 118, it's less than 120, it's 118 here. So my upper arm angle from the horizontal 0 degrees all the way to the upper arm angle is 180 plus 118 degrees. Those two added together should be 298 if I did my math correctly. So 298 degrees. Okay, so my upper arm is 298 degrees. I had my upper arm before as being, 328. I keep doing the same thing successfully. Now that I've got my arms, now I move to the torso. I'm going to find my torso angle based on putting my protractor crosshairs at the hip. That's occurring. My torso is pointing in an upward direction, so I keep my protractor upright. I know that I'm going from the 0, so from 0, the horizontal 0 degrees, up to this angle. I want to find out how large that is. You can see that it's going to be about 55 is where the torso crosses. Okay, so the torso angle is 55 degrees. That's a lot easier than the upper arms were. So 55 degrees. My upper leg angle, leg is also above the horizontal. I've moved towards my knees, put in my crosshair at the knees. I want to find from the horizontal 0 degree line axis, how big is that angle of my upper leg? Upper leg, I extend that out so that it does cross the protractor. I see that that angle is greater than 90 degrees. So using the 0 scale here, find that it crosses at about 133 degrees. So my upper leg angle was 133. And then finally, to find my lower leg, I'm going to put the protractor, I'm going to put the crosshairs down at the ankle, going from 0 degrees, going to extend my lower leg so that it crosses the protractor about right here, and so that angle is 0 up to about, I can see it crosses at about 50 degrees. Okay, so just putting those in the table again to finish that off. The lower arm was 328. The upper arm was 298. The torso was 55. The upper leg was 133, and the lower leg was 50. Okay, so that completes that one. And I see that, oops, I put in another practice for you. And so if you want to stop the recording at this point, measure these angles, come back and verify, I will give you the answers to this. And so if you want to pause it, stop it, take measurements, come back and double check your work, feel free to do that. So the answers to this are, again, for the lower arm, we put the crosshairs here. We'll put our protractor down here so that our protractor is upside down. We're looking for this total angle for our lower arm. That is going to be 301 degrees. For the upper arm, we put our crosshairs at the shoulder. Again, the upper arm's pointing downwards, so we put our protractor on this direction, downwards. We're going to be looking for the angle from 0 all the way to our upper arm. That angle is 235 degrees. And these numbers are approximate. If you move your protractor at all, it'll shift it off. There's a 1 or 2 or 3 degree error. And so if you've got 234, you've got 233, 232, 237, those are just fine. It's just a measurement error. So you're looking for very close to this, if not exact. Torso, put your crosshairs at the hip. You can see in this case our posture has changed. Our torso is pointing downwards below the horizontal, so we've got to put our protractor again upside down. Upside down, we're looking for the angle from the horizontal 0 degrees all the way over to here, over to the torso pointing down. Our torso in this case is 348 degrees. For the upper leg, crosshairs at the knee. Starting from our 0, our protractor, we can put our protractor upward. That angle from the 0 to the upper leg should be approximately 92 degrees. And then finally, crosshairs at the ankle for our lower leg, starting with our 0 line where it crosses the protractor. That angle should be 80 degrees. And then lastly, I've kind of skipped over this on the first problem, but if you're lifting or lowering a load, so what our homework assignment is, we've got a load in our hands. Gravity is pulling it downwards. Gravity is pulling it downwards. The angle of gravity, so the force angle of the load is the angle of gravity. That's going from 0 down to downward. That is 270 degrees. Okay, so gravity in this coordinate system is 270 degrees. On your biomechanical, the 2D biomechanical model in ErgoWeb, you can click and drag, you can measure with a goniometer, you can measure the angles on a picture with a protractor, and enter those numerical angles. All well and fine. If you get something that's impossible, such as this picture, you know you just have your angles wrong. You might have had the protractor upwards. You might have forgotten to add the 180 degrees to the angle. If you get something weirdly awkward like this that isn't possible, it's just you've probably measured your angle wrong. Go back and take another look at it.